Assalamualaikum and hello everyone. Welcome to the video for the solution for examples chapter 2 thermochemistry. Okay, initially I plan to do Google Meet this week to discuss some of the question, but then our timetable mostly clash with your math speaking test. So that's why I'm just going to give you the video for the solution. Okay, just that not all the question will be discussed in detail. Some of it you can just pause it and check whether you have the correct solution if you want. And then there are some examples where I will discuss it in detail. Okay, so first thing first, for chapter 2, we have learned 2.1 concept of enthalpy. Okay, so for the concept of enthalpy, mostly it is the basis of your chapter 2.3 for your Hess law as well as your Born-Haber Cycle. Okay, so for the examples here, I have included in the Google form, so you can check it there lah. Okay, so for the equation, I believe the struggling part is actually the enthalpy of formation. The struggling part is actually here, to know what is the stable element. So again, it is important for you to know what is the stable element for your atom, especially when you will do the Born-Haber cycle, the equation of enthalpy of formation. That's the part. So please be focusing on this part lah. Okay, so that's for chapter 2.1. Next, we have learned 2.3 Hess's law. Okay, so for our Hess's law, we know that it is used to determine our unknown enthalpy. Enthalpy is our delta H. And what is actually enthalpy? Enthalpy ni is actually heat of your reaction. Tapi kita usually define it as enthalpy lah. Okay, so for the enthalpy itself, to determine it, we can use two different methods. One is algebraic method. Another one is energy cycle diagram. So it's up to you which one you are comfortable with. But for me personally, I would prefer to do it in terms of algebraic method. Okay, so here is the video. Okay, so for the examples on page 6, I believe this is the examples that I want you to do. Okay, so if you want to check your solution, especially for the energy cycle diagram, you just can pause it, this part. Okay, next is actually on page 7. Okay, so page 5, page 6, I believe quite straightforward. Okay, so for example 7 and 8, okay, example 7 here, I have introduced you to use the delta H is equal to H product minus H reactant. Okay, but actually kalau dapat soalan ni, soalan bonus lah ni kiranya. Okay, so but then you have to know lah, for the product itself, make sure from our enthalpy of formation here, we have to multiply based on our, if you have to multiply, you have to check based upon your stoichiometry in the equation. But then I've asked you to do the extra examples for page 7 and 8 to do the algebraic method. Okay, so that is the part that I'm going to discuss. Okay, so for example 7 first, we're going to do it. So example number 7. Here we have the question asks you to determine the enthalpy change for the reaction. Okay, to determine the enthalpy change, here is our unknown. Okay, so for the algebraic method, okay, how to know the equation? What you have to do first is, from all the information here, you have to write down the equation. Then you can rearrange it to get this unknown. Okay, so again, this is enthalpy of formation. So it means that 1 mole of each of the species will form. So that's why I've put it here. Okay, again, hint for the enthalpy of formation. Okay, for example, here we have H2O kan. Okay, H2O is our molecule. It's our product here. Okay, when we see based on the molecule itself, we know that H2O must come from H dengan O. Okay, but then, because formation is actually when 1 mole of product is formed from its stable element. So, hydrogen, stable element dia adalah H2 gas. Oxygen is O2 gas. So, here, O2, H2. But you have to include the phase as well lah. Ni 1NO gas. So, NO originally from NO. Okay, and what is the stable element? Is N2. Oxygen, what is the stable element? O2. Okay, and then you have to make it balance. Okay, this part, HNO3. So, HNO3, we have extra 1 atom kan? It means that we have hydrogen, we have nitrogen, we have oxygen. Okay, H, stable element H2, and N2, O pun O2. Okay, then you have to make sure the equation is balanced lah. Okay, and then make sure, since this is the formation, It must be 1 mole of product. Okay, so here is the equation itself, which siapa yang buat 2.1 tu, this is actually I have included this question as your extra question in 2.1. Okay, so from here, how do we rearrange it to get this unknown? Okay, so first, we have H2O liquid. From our unknown, H2O where? H2O is actually here on the reactant side. So what should we do from this equation? We have to change the position. Once we have changed the position, the sign also have to change. Next equation is NO gas. Okay, from our unknown, NO gas is actually on the product side. So it's still the same. You don't have to multiply anything. You're just gonna let it be lah. Take it as it is. Next one, NO2 gas from the equation on the product side, but for the unknown, it's actually on the reactant side. Okay, that is not the only differences. From here, when you see it, here we have 3 mole of NO2. But here we have 1 mole. So what should we do? Not only we're going to change the position, we have to multiply all of this by 3. Not only the stoichiometry here, the value here pun, you have to change it into negative and then times 3. Last but not least is HNO3 aqueous. So we look our unknown HNO3 on our product side. But here we have 2 moles. So we have to multiply all of this by 2. Okay, so once you have make the changes here, so this is the equation. Okay, actually from this equation, all of this equation, you should be able to get this part. Okay, so let's do it together. Okay, H2O is the other thing that we want, so we're just gonna let it be. Hydrogen gas, here we have our hydrogen gas. Opposite side, we're gonna cancel. So we're just gonna cancel it out. So here, cancel H2, cancel H2. Next, we have half O2. Here we have half O2. Okay, so opposite side, senang nampak, cancel. Okay. Next, we have half N2. Okay, half N2 here, but here we have 3/2 N2. How can we cancel it out? Okay, as we can see here, here half N2, here is 1 kan. So, total of this is actually 3/2 N2. Here on the opposite side pun 3/2 N2. So, again, cancel. Semua cancel. Okay, NO gas is the species that we want. 3NO2 gas is the species that we want, so jangan cancel. Here, ada lagi oxygen. Okay, but then here, oxygen ni, it can be cancelled out by this oxygen, so cancel. Then what we have left is actually 2HNO3. And then this is the equation, the same as our unknown here. Then we will get the delta H. Okay, so this part, it seems quite a lot because it seems like a lot of species je pun sebenarnya. Okay, so that is for question 7. Next is for question 8. So for question 8 itself, okay, the same thing, but then here we have, they ask you to calculate the enthalpy change. Okay, so they give you the enthalpy of formation of ammonia. If you do not know what is ammonia, at least kat sini dia bagi tahu NH3 gas. Hydrogen chloride is HCl. Ammonium chloride, the formula is NH4Cl. Okay, again, the same thing. Okay, so NH3, so it means that our species is N and hydrogen. Okay, N, when we check it here, N dengan hydrogen, N stable element N2, hydrogen stable element H2. So then you have to make sure it balanced to form 1 mole of NH3. So HCl, HCl lain nampak senang. H dengan Cl lah. But then what is the stable element? H2 and Cl. Here sepatutnya ada Cl2 lah. Cl2. So here is actually the part that I mentioned yang quite tricky part is actually to determine the stable element. Okay, so once you have found your equation, you can just rearrange it. Because here is quite straightforward. NH3 and HCl based upon the equation is on the product side. But for the unknown itself, it is actually on the reactant side. So both of this equation is, what we're going to do is actually change the position. And then change the sign as well lah. And the NH4Cl, you're just going to take it as it is. So next what you have to do is actually you have to rearrange it. So let's do the cancelling part together again. NH3 is the thing that we want. So half N2. So N2 we have here and 2. So we're going to cancel it out. Cancel. And then 3 over 2 H2. But here we have 1 over 2 H2. It is same side kan? So if it's same side, we have to add it. Then here we get 2 H2 gas. Here we get 2 H2. So we can cancel this one. H2 yang ni, half H2, 3 over 2 H2. Okay. HCl, we want it to be there. Here we have half Cl2 pun cancel. Half Cl2, half Cl2. So this is actually our equation that we get from simplifying, which is the same as our unknown. Then we will get our delta H. Okay, so that's for question 7 and 8, which is your extra question lah. Okay. Tu je. Next, what we're going to look at is actually the dissolution of ionic solid. Dissolution of ionic solid ni, you have to answer it because the question, because you have to answer it, the question usually asks you to draw the energy cycle diagram. So this part memang kena buat energy cycle diagram lah. So this is actually the solution for example 2, your examples. So you can check it if you want, you can pause it if you want. Again, to calculate the enthalpy of solution ni, here we have our formula ni kan. Solution equal to hydration minus lattice. Okay, bunyi plain, whatever lah. Okay, so sekarang ni, from the equation, for example, if you don't want to memorize this part, actually you can answer in terms of algebraic method. But then again, for the algebraic method, make sure you know for the specific enthalpy, what is the species involved? Is it gas? Is it aqueous? Which one yang 1 mole? So that's why here basis dia memang kena from our 2.1. So again, if you want to do the algebraic method, here is the solution. Okay, next subtopic we're going to look at, ini yang paling penting ni, 2.4 Born-Haber Cycle. Okay, so for the Born-Haber Cycle, we will be focusing on formation. Yang ini nanti pening ni kan, formation, because here, stable element. This is the part, the stable element. And then atomization, stable element juga, tapi from 1 mole of atom. Ionization energy is actually when the atoms here lose electron. Kalau electron affinity is actually 1 mole of atom ni, dia gain electron. And then the lattice energy is actually when our gaseous ion will form our ionic solid. Okay, so based on the examples here, okay, examples 2 I've asked you to try yourself. But then again, for example 2, first thing first, you have to write down the equation. So if you just want to check here, you just can pause it here. And then example 3 and 4. Example 3, we've done it together. Example 4 is similar as example 3. It's just that here we have another ionic compound. Okay, so here we have about our MgCl2. The question asks for MgCl2. So for the MgCl2, when 1 mole of this is actually the formation kan. So MgCl2 maknanya it is formed from Mg plus Cl, right? And magnesium is actually our group 2 metal. So here is solid. Chlorine originally is Cl2 lah dekat sini, Cl2 gas as well. So this equation is balanced as it is. Macam ni dah balance dah. Okay. It's just that for this part, yang tricky part dia is actually here. Because from the information, what we have is enthalpy of atomization, which is 240. Okay, this is the equation of atomization, right? Okay, but then when you draw the Born-Haber cycle itself, here is actually Cl2 ni, maknanya from Cl2, we know that 1 mole of atom is forming kan. But then again, sini we can't write down half, sebab this equation is balanced already from our formation. So what should we do here? So actually, yang ini dah ada lain sikit part dia. It's actually you have to add 2 in front of the chlorine. So when you add 2 in front of the chlorine itself, so the equation is not based upon, the value won't be the same as atomization lah. So what happened to the value? So here we have to multiply by 2. Okay, so this is the part here. Okay, and then for the electron affinity pula, electron affinity is actually chlorine gas will become Cl minus gas. Then this equation dah jadi 2Cl gas forming 2Cl minus gas. Again, kena buat both side as 2 to make sure the equation is balanced. Kalau 2Cl gas jadi Cl minus gas. Mana balance? You have to add 2 here. So, the value pun kenalah multiply by 2. Sebab equation yang ni, electron affinity here is Cl becoming Cl minus. Okay, so that is the equation. Okay, and then sebenarnya hint for you, for the Born-Haber cycle, okay, except usually dekat sini lah, most of the case, only the product here and the starting of our atom here usually, that is the only solid. Yang lain ni semua kita akan gunakan gas phase. Okay, so that is actually for Born-Haber cycle. Kalau phase kamu pening, okay, what happens is actually yang our formation of product yang solid tu dengan yang start with our metal. We start our metal. Metal is actually a solid lah. Okay, yang lain semua ni akan jadi gas. Okay, so that is actually for example 4. Okay, example 5, I've asked you to do yourself as well. Okay, kan copper 2 oxide kan? So, copper again Cu2 plus, O2 minus. So, that's why we get CuO. Okay, tapi again, for the formation, dia adalah CuO, originally copper dengan oxygen. Copper is a metal, transition metal, so solid. Oxygen is O2, gas. Okay, tapi dekat sini, because we want to make it balance, kan O ni kan satu saja, so you have to make it half here. Yang tadi tu kan memang dah, contohnya sini Cl2, so that's why you just gonna let it be there. Tapi yang dalam case ni, sebab oxygen is 1, so here we have to make the oxygen as 1. So ni macam kita punya yang the first starting kita belajar, Born-Haber cycle. It's just that yang ini ada extra sikit, because not only we have 2 ionization energy, IE1, IE2, we also have 2 electron affinity. For the case of our ionization energy, mana? Ionization energy ni and electron affinity ni, we have to do step by step. So, maknanya, we can't do Cu gas, jadi terus Cu2 plus gas. And then, tak boleh delta H, you gonna add these 2 value. Cannot lah. You have to do one by one. From the Cu gas, first ionization, from Cu plus. Then the second ionization is Cu2 plus. Okay, the same goes for the oxygen because we have first and second. So we have to do first O minus, then we become O2 minus. Okay, so that is for example number 5. Okay, ni example number 6 ni, we have done it together. Tapi sebenarnya sini miss yang ada tu confuse. Here is H1, enthalpy of formation. Here is H2, our enthalpy of atomization. Here sebenarnya ni H4 tau. So sebenarnya ionization ni is actually our H4. I assume here yang jadi, I assume my fault actually here yang 1, 2, 3, 4. Sebenarnya tak, tengok sini. Ni 1, ni 2, ni 3, sini 4. So here is actually H3. So betulkan sini, here is my delta H3. Enthalpy of atomization. Okay. Next is actually example 7. We have done it together. Example 8. Okay, you just can pause it here, check whether you get the correct enthalpy. So for the enthalpy, you have to write down specifically of what? Ionization energy of what? Is it rubidium? Rubidium iodide? Or boleh je ionization energy of iodide. So that's why we have to be specific lah of what. Okay, so that's for question 8. So for question 9 and 10, here's the difference. Is actually they ask you to determine the electron affinity and the ionization energy. Previously, mostly ask for lattice energy ataupun formation kan. So this part actually memang nak tak nak, first you must be able to write down the equation. Okay, so for the CaCl2 part, okay, when you write down CaCl2, because Ca2 plus Cl minus, so we become CaCl2 lah. And then from here, when we balance it out, so here is calcium solid and Cl2 gas. So again, this is enthalpy of atomization is actually when half Cl2 become Cl. This equation is ini enthalpy of atomization kan. Tapi this equation Cl2 become 2Cl. So we have to multiply this value by 2 to get this value. So that's why lah, multiply by 2. And then the same goes for electron affinity. The question asks for electron affinity. Okay, so when you edit all the value here, electron affinity ni is actually, you have to know, it's actually 2x. Because electron affinity times 2 kan, based on this value itself. So when you get this answer to be negative 698, that is actually, it's true the affinity. The value here is actually for the affinity of your 2Cl gas become Cl minus gas. It's actually this part kan. 2Cl gas jadi 2Cl minus gas. But actually, here is not the lattice and that is not the, what do you call that, electron affinity. Electron affinity is 1 mole of your gaseous atom. So sebab tu lah kita kena divide all this value to get yang Cl gas jadi Cl minus gas. So here is actually our unknown enthalpy kan. Ni enthalpy biasa je. Ini baru electron affinity. 1 mole of your atom gain electron to form negative ion. So that's why you have to divide by 2. Okay, for this part. Okay. So that's for question number 9. So for question number 10, yang ini I believe is quite straightforward lah. Yang ini sebab IE2 you don't have to multiply by any value ke apa. So you just gonna take it as it is. Remember for the file ni, Born-Haber, as you can see most of it, only the last part, the product and the metal sahaja solid. Yang lain semua gas. Usually dekat part sini senang je, ada 1 mole. For this part, yang ini yang kena check lah. Kalau sini, kalau is it correct? The equation of atomization betul ke? Sama ke dengan kita punya Born-Haber cycle? If it's not, you have to multiply by 2. Usually pun paling lain pun you have to multiply by 2. Just now yang multiply by 3 ke, divide half ke, tak ada. Itu sahaja for the Born-Haber cycle. Okay, last but not least, kita akan tengok for the calorimeter. Okay, so for the calorimeter, remember, if anything, you have to look based upon the information given. So kita tahu kita ada Q equal to MCAT atau MCAT plus CAT, depends on the question itself lah. What is the information given? Okay, and then the MCAT plus CAT tu is actually heat of the reaction, yang heat release to the surrounding. If the question involving delta H ni enthalpy. Enthalpy ni is actually heat of the surrounding divided by the number of mole. Okay, so we will get a negative value. Even though when you calculate the value, you won't get negative, you have to add in yourself. Why? Because the definition of combustion is heat release. So when heat is released, so we have to include the negative at the end of our equation. Okay, and then make sure you have to look based upon your standard calorimeter. The heat capacity. If the unit is kilo, you include the kilojoule. Okay. So start. Okay. Here is the example 567, which I asked you to do yourself. So you can pause it and check whether you get the correct one. Okay. And then for this part, it's actually for me it is easier for you. For the Q especially, actually I would like to use the joule lah. Usually the question does not specifically minta kilojoule per mole, so it's fine. Sometimes if you be confused whether the answer is in kilojoule per mole ke joule per mole, when you do the calculation, label lah your answer Q2 first. So when you substitute the value, tengoklah sini dah kilojoule per mole, straight away the answer is kilojoule per mole. Here for this calculation, the Q we get in joule. So the first answer is joule per mole. Later when you divide it, you get kilojoule per mole. Okay. And then question 7, same question 8, the video I have discussed in the video. Okay, yang for question number 9 ni, 9 until 11 is the same case, where again, memang value of delta H is given to you is a negative value. But when you calculate it, negative tu is not included tau. Negative ni tak perlu ada pun. Because again, the negative just want to show it to you that the heat is released from the reaction. Okay, then you can get the reaction itself lah. Okay, and then when you calculate it, your Q you get in kilojoule. I would prefer to write down my Q in Joule itself sebab nanti senang Miss nak substitute this value. Bila Q ni Joule lagi senang lah actually, especially kalau MCAT sahaja. Contohnya when we look at this part of question 9 ni, we can see here 500 ml of water. Okay, tapi kenapa dekat sini ada MCAT? Why we use CAT? Sebab here volume ni kita akan jadi mass because density is 1. But then for the heat capacity of water in the question tak ada. But then this is actually in your list of constant. So for the CW it depends. Sometimes it does not given to you. It is not given to you in the question. You have to look based upon list of constant. So here is question number 10. Jom kita tengok yang question number 11 ni. So here for example it gives to you 0.5 kilogram of water. Okay, so we know that we're gonna use mass of water lah. But from the question itself, we don't have any CW. So where is the CW? Okay, CW again is actually from your list of constant. So I have just written down it here. Ta-da! Okay, so that is actually the solution. So you just can pause it here, check. Q is equal to MCAT plus CAT. Depends on the question. What is the information given? Walaupun CW is not given, when you see mass of water, you're going to take the CW too from your list of constant. And last but not least is the enthalpy of solution. Enthalpy of neutralization actually. This is quite a lot of steps, so you can check it by yourself. An explanation tu bolehlah tengok pada the original video. So that's it for this video.